All right, we are going to wrap up chapter 5 today. So, we're going to start by talking about the explanation for each of the trends that we observe in the periodic table. And then I'm going to review each of the trends and how they increase. So, you're going to need that periodic table that you've been using in the trend setter activity. All right, so we're going to talk about the explanation for why the trends happen within a group. So just as a reminder, the group is a vertical column on the periodic table. All right. So here's when we talk about group and explanation, let's look at it in terms of as we're going down a group. So we're starting at the top of the column and we're working our way to the bottom of the column. So all of our explanations revolve around what we know in terms of electron configuration. So here's what we observe, that electrons are going to occupy sublevels that are in higher energy levels as we go down a group. So if we're putting electrons in higher energy levels, it means that electrons are going to be further from the nucleus. And what this also means is that we're going to have more core electrons. And remember that the core electrons are all of the electrons that are not in the outermost energy level. So if we have more core electrons, then what we observe happening is that there's an increase in electron shielding. So basically what this means is that you have more electrons that are blocking the pull of the nucleus on those electrons that are in the valence shell. Okay, so let's talk about an explanation for what happens within a period. So when we talk about a period explanation, we're going to go from the left. So we should know that periods are the horizontal rows on the periodic table. And when we're talking about a period trend explanation, we're talking about going from the left to the right side of the periodic table. All right, now let's start with the role electron configuration plays. We should recognize that as you go from left to right across the periodic table, that in this case, the electrons are being added to the same energy level. So this would tell us that the number of core electrons are not changing. And if that's the case, then what we observe is that the electron shielding remains the same. Okay, so if it's not electron configuration, then let's look at what else there we could have going on here. We know that as we go from one element to the next on the periodic table, the atomic number is changing by 1. And we know that the atomic number is representing the number of protons. So in other words, the amount of positive charge is increasing by 1. So we have an increase in positive charge. And you may recall from an earlier chapter, this is referred to as nuclear charge. So if the positive charge is increasing, there's a greater attraction on electrons. So that nucleus is pulling electrons toward it. Okay, so let's look at that periodic table that we have from Trendsetter Part 1. And let's look at the trends you would have recorded. All right, so you were to draw an arrow. Let's start with atomic radius and ionic radius because they have the same trend. And let's start with the group trend. So you were to draw an arrow that shows me the direction in which the atomic radii and the ionic radii increases. And then you were to label your arrow. So again, simply put, if you're adding energy levels, the atom's going to get bigger. Okay. All right, so let's look at the period. So again, you're to draw an arrow that shows the direction in which the atomic radii and the ionic radii increases. So I'm going to draw mine up here at the top. Because remember, as we go across left to right, the elements on the right side have a greater positive charge. They're going to pull in those electrons toward it. So we see that the atoms get smaller. Okay. So the biggest atoms on the periodic table are going to be the ones in the lower left-hand corner. All right, and then let's review your answers for ionization energy. So ionization energy, if we're talking about how it increases for a group, the elements that have the bigger ionization energy are going to be at the top of the group. Those would have electrons that are closer to the nucleus, which makes it harder to pull electrons away from. All right, let's look at a period. So in a period, ionization energy is going to increase as you go from left to right. Again, if the atoms are smaller and have a greater charge, it makes it more difficult to pull electrons away from it. And that's what we're looking at in ionization energy, the removal of electrons. Okay, let's look at electron affinity. So electron affinity is the energy needed to add an electron. And for this case, the more negative it is, it has the bigger electron affinity value. And then across a period, electron affinity increases. Okay, so what ionization energy and electron affinity tells me are what kinds of ions these elements are most likely to form. All right, so elements that have a lower ionization energy are going to be the ones most likely to give up an electron. So we can see that's the elements on the left side of the periodic table, and those would be our metals. So metals are going to form cations. And we can see the elements that have a higher ionization energy but are most likely to accept an electron are on the right side of the periodic table. So this tells me that nonmetals are most likely to gain electrons, and they're going to be the elements that are going to form your negative ions, also known as an anion. All right, and then the last trend is electronegativity. So electronegativity, that's the arrow for within a group. And then here's my arrow within a period. And this tells me the attraction an element has for electrons. So when I look at this, I can see elements that are in the upper right-hand corner. So if I'm going to pick one, I'm going to pick fluorine. It's going to be the most electronegative element on the periodic table. So fluorine has a great attraction for electrons.